Welcome back, everyone. We're going to go through one more problem of graphing a vertex form. Just a quick review. Remember, vertex form is y equals a times a quantity x minus h, that quantity squared, plus k. A tells us whether the problem opens up or down. H and k is a vertex. X is a symmetry. It's just that vertical line through the vertex, which is going to be x equals h. So the last video we did the first problem. We'll take some time and go over the second problem in this video. So if we have y equals 1/5 times a quantity x minus 4 squared plus 2, we know from the a value, with it being negative, that this problem is going to open down. We also know since that a value, the absolute value, is less than 1, this is going to be wide. Remember, the smaller a is, the wider it gets. The bigger a is, the skinnier it gets. And then because it's in vertex form, we can find the vertex by looking at the h value and the k value. The vertex is going to be 4, 2. Remember, whatever you see inside the parentheses, do the opposite of that. We see a minus 4, so the vertex is going to be a positive 4 for the x part. And whatever the k is, same. Axis of symmetry is going to be the line x equals the x part of a vertex. The y-intercept we find by letting x be 0. So if x is 0, we have y equals negative 1/5 times 0 minus 4 at quantity squared plus 2. So 0 minus 4 is negative 4. Square root of 16 times negative 1/5 gives us negative 16/5. If we want to find a common denominator, we can change that 2 into 10/5 and get negative 6/5 for the y part of our y-intercept. And at this point, remember, we're going to graph everything we have. So we have a vertex at 4, 2. We have a axis symmetry at x equals 4. And a y-intercept of 0, negative 6/5, which is about here. Now for that point of symmetry, that's going to be on the other side. Actually use a different color. That's going to be on the other side of our axis of symmetry. So it's easier to do from the graph, and if we count from our y-intercept over the axis of symmetry, it is 4 units. So we're going to go 4 units in the other direction, and there's our point of symmetry. So this is at 4, 2, and we want 4 more units over. This is going to be at 8, negative 6/5. And then remember, the last part is our x-intercepts. And again, we save that for last because sometimes we can save ourselves a little bit of time. Again, in this case, we're going to have x-intercepts right here and right here. And we want to find those by solving a quadratic equation where the y value is 0. Let me get that set up. So if the y value is 0, we end up with 0 equals negative 1/5 times x minus 4 that quantity squared plus 2. Again, you can take at x minus 4 and square it. Multiply that answer by negative 1/5. Add 2. And you would end up with negative 1/5 times x squared plus 8/5 x minus 16/5 plus 2. You have 0 equals negative 1/5 x squared plus 8/5 x. And we know this would end up giving us minus 6/5. If you multiply everything by 5 on both sides, you end up with 0 equals negative x squared plus 8x minus 6. And then you could go from there and use the quadratic formula. Nothing wrong with that at all. Little shortcut though, if you're in vertex form, you can solve this equation by getting the quantity squared all by itself. We'll subtract 2 from both sides. We're going to multiply both sides by negative 5. And then square root both sides, putting in the plus or minus with our radical. Then add 4 to both sides. We end up with 4 plus or minus the square root of 10 is equal to x. Those are our x-intercepts. We have 4 plus the square root of 10, comma 0, and 4 minus the square root of 10, comma 0. Again, you could put those values in a calculator to find out approximately where to plot the points. So I know square root of 10 is just over 3. So 4 plus 3 is going to be 7. So our one x-intercept is just past 7. 4, 5, 7, about there. And then 4 minus square root of 10 is going to be just under 1. Once we have those points, connect them with a U-shaped curve, and we have our parabola. So again, most of this, and this will always be given to you, opening up or down, wide scaling average, vertex, axis symmetry, y-intercept, point of symmetry, x-intercepts. You don't have to remember what to find, but you do have to know how to find them. So again, the A value tells you if it opens up or down, and whether it's skinny, wide, or average. That's all from the A value. Your H and your K in your vertex form give you the vertex itself, as well as your axis symmetry. Once you have those two things, and we go to y-intercept, that's just a little bit of algebra where you're going to let x equal 0 and then solve when x is 0. You're going to plug in. And once we have those 5 things, we can plot what we have. We have a vertex, we have our y-intercept, and we also have our axis of symmetry. So with those 3 pieces, then we can find a symmetric point by going the same number of units from the axis symmetry to the y-intercept, get the same number of units in the other direction. So we knew this was 4 units along here, So this has to be 4 units here. That gives us a symmetry point. X-intercepts are take the most time, so we save them for last. Again, remember that if your graph is never going to cross the x-axis, there's no x-intercepts. You have something like this. You have something like this. Or if the vertex is on the x-axis, then your x-intercepts and your vertex are the same point. That's why we save them for last. Sometimes we can save ourselves some time. Again, for something like this, we see it crosses the x-axis, so we do have to find those intercepts. And we do that by letting y be 0. And you have a couple different methods. You can use quadratic formula that we've looked at. It just takes a little bit of time to put it into standard form. Or you can use this idea here of getting the quantity squared by itself and using square root to get the x value all by itself. And it's just a matter of plotting all those together and putting all information together and connecting the points that you find. All right, so I'll stop there for now.